Tips for level 3. All right, we're here near the real deal. This is how we do them. You determine that a rock has 2.5 grams of uranium-238 and 37.5 grams of lead-206. I don't want to give you the answer for this one because there's only one of them, but I think I have another one like this somewhere so I can help you with it. All right, this one's good. An alien visit. This is a level 3. An alien visits you one day. The alien says its home planet is very old, running out of resources. To prove the planet's age, it gives you a cool-looking rock. You know, it's got 25 grams of rubidium-87 and 175 grams of strontium-87. What percent of the rock is paranisotope? You have to figure out the percent using the data or the information given. So let's write down a couple things. That's going to come in handy. We have 25 grams of rubidium 87 and 175 grams of, what was it, strontium 87. Okay. Notice these numbers are just the names of the elements or the isotopes, nothing to do with the age. All right. Has something to do with the protons and neutrons. So first, what I would do is I would check this. Which one is the apparent isotope? Our rubidium is. We know that. All right. So this is the apparent isotope. I'm just write PI here. This is the daughter isotope, DI. We have to figure out what percent these represent. How do you go from grams to percent? Think about it like you have a test, right? If your test has 100 questions on it and you got 80 of them correct, right? You got 80 correct, 20 wrong. Well, if there's 100 questions total and you got 80 out of 100, you know you got 80%. For level 3, you have to figure out the percent composition, right? So you have to know, and for this case, I'll give you a formula. The grams of the isotope that you're looking for, the grams of the total amount of isotopes times 100%, that'll give you the percent of the isotope that you're looking for, right, of this isotope. So first we gotta find the total. How many grams are there total? First, let's go back. Remember the rock. Remember that when a rock is first formed, it has 100% of the radioactive isotope is still there. There's no daughter isotope. So what you can think of is that this strontium-87, this used to be this rubidium. So at one time, it was all of this, all of these grams were rubidium. So how much was there altogether in the beginning? Let's add it. 0, 7, 8, 9, 10, 0. 200 grams total. Interesting. So there were 200 grams total when this all started of rubidium. And after a half-life, you can think, I mean, in my head, I'm already thinking, which is what you should be thinking at this level. After one half-life, how much rubidium would there be left? 100 grams of rubidium, 100 grams of strontium. After 2 half-lives, how much would be left? I'm thinking 50 rubidium, 150, right? Something like that. So this question's difficult. So 200 grams total, right? So the isotope. So we know, using our calculation, our formula, 200 grams total times 100%. So we need how many grams of the isotope? So let's find out rubidium first, 25 grams. So 25 divided by 200. I have a calculator here. Is 0.125 times 100 is 12.5% rubidium-87. And we can do the same formula for the strontium. Or you can just do simple math, right? You know it's going to be 100% total, so you can do 100% minus 12.5. But how much did we have? We had 175 of the strontium. Calculator, 175 divided by 200 equals 87.875 times 100%, 87.5% of strontium-87. So there you have it. But the question's asking you, what percent is the parent isotope? Well, we know just by looking at the table, right? The worksheet has a table. Rubidium-87 is the parent isotope. So the answer would be, this is how much of the parent isotope there is. This is how much of the daughter isotope there is. Then after you have that, it's all easy, right? 12.5%, what does it ask you? What percent of, how many half-lives have passed? Well, you got 12.5 of the parent isotope. You just use this. 3 half-lives passed. How long has that been? Well, we're going to just use simple math, right? We know 3 half-lives have passed, and we know how long 1 half-life is. 1 half-life is 47 billion years. Times 47 billion years. It's 1,000, million, billion. That's billion. Trillion, billion, million. Wow, that's an old rock, years old. That rock definitely is not from this planet or the solar system even. So that alien pretty much has proved to you that they are from a faraway distant, at least solar system, because they have a rock that's older than anything that we have ever seen anywhere near us. Remember, use the table.